As you can see on Team Frowny's differential gear set, the spur gears located on the side are of a 1:2 ratio. This means that the larger spur gear spins at half the speed of the smaller spur gear. Seeing as differential gear sets have an average output of the two inputs, if we hold one input steady and spin the other, it should take 4 spins of the smaller spur gear to make one full revolution of the output sprocket, demonstrated now. That was 1 full revolution, 2 full revolutions, 3 full revolutions, and 1 final revolution of the smallest spur gear. You can see that the sprocket has now made 1 complete revolution. Now we're going to spin both shafts in the same direction, which means that the sprocket should make 1 full revolution by the time that the 2 shafts make 2 full revolutions. Watch the set screws now. This will be the first revolution, and now the second revolution. And the sprocket is back in the same exact spot. So, now we're going to spin both shafts in opposite directions. This means the differential and the sprocket should not move during this rotation. As you can see, with some minor movement, the sprocket is remaining mostly still. In the next part of this segment, you're going to see the gearbox in its more natural habitat, also just known as rotating at a much higher RPM. So as you can see from this chart, input A is being held steady at 0 RPMs, while input B will be at 600 RPMs. Since these are going to be on a 1:2 ratio, 0 on a 1:2 ratio is still 0. However, the 600 RPMs will be reduced to 300 RPMs. After that, it will go to the differential, and the output of the differential is always the average of the two. The average of 300 and 0 is 150 RPMs, and now to prove this, here's a small video segment of this being explained.